So please go ahead.
Thanks, Benno. Thank you. This has been a wonderful workshop so far. This is my first time, so I've had a lovely time. I feel like, that meme with Big Bird in the meeting where everybody else knows what they're doing. This is going to be a philosophy talk. It's great to be scheduled immediately after lunch when everybody is happy and has a food coma. The lucky thing for you is that even though I'm used to giving talks that last an hour, there are no technical results. This is basically just kind of primary school show and tell. I'm going to not try and prove anything, but just give you an example of 5 different things that I see are interesting connections between considerations in type theory and things that I've seen in other areas of philosophical logic. So first, the introduction. I don't do work in type theory. I've worked in other areas of logic. In particular, I've been interested in the kinds of things that you can see from multiple different perspectives. A book that I wrote in the last century on substructural logics arose because I noticed that things in relevant logics in philosophy, linear logic in proof theory, and then being applied in computer science, and the Lambert calculus in linguistics, people were inventing the same sort of thing for very many different reasons, and results and techniques and insights from one area could be applied to another. And so that's the kind of work that I like doing. And it seems that most of the interesting work that's being done in this formal area of research these days is being done in type theory. So I'm really interested in learning about type theory. And so I'm going to tell you some of the connections that I see. So I'll start closer to home ground in thinking about modal and substructural logics, and then things will get more sort of conjectural and weird by the time we get to the end. So modal logics are a massive industry. Not only in sort of philosophical logic, where philosophers are interested in, notions of metaphysical necessity. It's also been applied in terms of reasoning about knowledge, in dynamic epistemic logics and all of those sorts of applications. It's also the kind of thing that gets applied in linguistics, in sort of Montague and other kinds of compositional semantics for natural languages. The tools of modal logic are used everywhere, but the vast majority of research in modal logic uses Kripke semantics. This is a sort of a great tool which models the truth conditions for modal expressions in terms of whether or not something is true in this circumstance related to other circumstances. And when you see it, those sorts of tools, the connection between those and sort of type theoretic considerations seems to me to be adequate, but not as good as you might have. That gives you truth conditions for things, but not so much why something is true or a witness for its construction or something like that. There's a minority tradition, which I think is really, really interesting in modal logic, but you've got to go digging to find it, is in the algebraic tradition. Of trying to give sort of algebraic representations for notions of possibility and necessity. And so when people notice that whenever you had a binary relation, you could look down it forwards or look at it backwards, which became most obvious when thinking about modal representation of temporal reasoning, then people noticed, aha, we've got this really interesting sort of connection. If whenever something had happened in the past, if it had happened in the past at some time that A was true, if whenever that happens, B happens to be true now, then it's also true that whenever A is true, then at all times in the future, B is true. This is that little double-line inference rule that I have on the left. This is understood as a residuation or a Galois connection or an adjunction. And that way of representing modal algebras is very, very interesting. It generalizes naturally to categories, and so it has an interesting kind of type theoretical interpretation. That's something I think more people should know about. In fact, we notice that more clearly in the kind of substructural setting of sort of linear logic, relevant logic, affine logic, and all of these sorts of things, where you have this similar residuation kind of condition or Galois connection or adjunction between some kind of combination on the left think of it as a sort of a generalized multiplicative conjunction, and an implication type operator on the right. And this is the kind of thing that lots of people discovered in independent ways when we're looking at these sorts of logics, and we're interested in ways of combining things which generalize from Cartesian closure to monoidal categories or other things like that. Now, it's less known, at least in a crowd like this, that the kind of Kripke models for modal logics generalize to a substructural setting where instead of having two-place binary relational semantics for a one-place operator of box or diamond, you have a three-place ternary relational semantics for two-place operators of conjunction and implication. And this is where you get the kind of ternary relational semantics for substructural logics, which again are interesting sorts of models, generalizing distributive lattices by having these operators on them, and generalizing them to the non-distributive sort of linear logic setting turns out to be interesting. There's lots of connections there, but many of you know about this. So let's move to more speculative, interesting connections between sort of philosophical logic and type theory, and that's one is identity. It's wonderful coming to a type theory conference because you realize that expressions like this that philosophers tend to say are true in one sense and absolutely and utterly untrue in others. It's wonderful coming to a conference like this and people are complicating identity by saying maybe identity goes from the left to the right, but not the right to the left. Or it turns out that there's different ways that things can be identical to themselves or other things like this. This is all true. Meanwhile, it's also true that everything is identical to itself and is not identical to anything that isn't itself. I mean, that's sort of obvious as well. That doesn't answer all of the questions between the interaction between identity and what it is to be a proof of identity, identity and the notion of necessity, identity and what it is to construct, or especially the relationships between identity and isomorphism. Philosophers have been worrying about this sort of thing for a long time. And some of their connections, I think, are going to be useful, and other things the philosophers can be learning from you, type theorists. People have known forever that identity and necessity interact interestingly. You know, 8 is the number of the planets. I think, I don't know, I'm not an astronomer. It used to be 9, but we were wrong. It turns out that there's only 8 planets. It's necessary that 8 is 8. 8 can't be anything other than 8, but it's not necessary that the number of planets be 8. I mean, if you had a big enough gun, I suppose, or moved one of the planets so that it was elsewhere, then the number of planets would be 7 in this solar system, or if you made a new one. Now, how does that work? How does that work if identity is going to be something like identity, if 8 is the number of the planets? Well, this is why God invented brackets, right? God invented brackets so that we could say that it's necessary that the number of planets is 8. No, that's not true. But the number of planets has the property that it's necessarily 8. If you put the description phrase outside the brackets and put the necessity inside, that seems reasonable. Whereas if you put the description phrase inside the necessity claim, that's not. That's a de re de dicto distinction, just fancy name for brackets. Same goes, although more subtly, when it comes to intentional notions of, say, knowledge or evidence. Clark Kent is Superman, I reckon. Lois Lane knows that Clark Kent is Clark Kent. Does it follow from that that Lois Lane knows that Clark Kent is Superman? I mean, the stories would be different if that just happened automatically. Fx equals y. Lois Lane knows that y equals y. Does Lois Lane know how to calculate the bloody complicated function f? Not necessarily. What the hell is going on here? Well, I mean, Frege said, an important and interesting thing is that S and T can be identical just when S and T have the same value. That doesn't mean that the terms S and the term T have the same sense. They get to the value in the same sort of way. Philosophers have been worrying about that for a long time, but they haven't had the interesting and rich kinds of models that are being invented in type theory to think about this. And here, the closest connection, and this is being done by people who know this tradition, in particular folks like Colin McClarty and Steve Audi and others, this is connected with in the area of mathematics to try and figure out, you know, when is it that, you know, G1 and G2 are the same group? Well, you know, considered as groups, we've got a story about group isomorphism. but the relationship between isomorphism and identity is a subtle and an interesting one. But one way of, as a philosopher, of thinking about this is that what makes that subtle and interesting is we're trying to decide what kind of thing a group is. And identity is clear for things that you already know what they are. But if you're trying to invent something and invent theories about something, settling identities and settling what it takes for X to be identical to Y is part of the subject matter of settling what it is that you're talking about. So be impressed that you're thinking about deep things. Next, the relationship between classical and constructive logic. Proof theory loves constructive logic. Okay. Gensen, Heiting, and moving into philosophy, folks like Dummett, Per-Martin Neuf, Doug Pravitz, Jean-Yves Girard, many people have explored the relationship between proof theoretic understanding of logical consequence and understanding the structure of deduction in such a way that there seems to be a natural grain not only towards identifying intuitionist logic and things in that sort of family, but also giving us interesting perspectives on the relationship between that and classical reasoning. Understanding the boundary between classical and constructive reasoning is a live issue in philosophy as well as in other areas of, conceptual inquiry. We've known for decades, for more than half a century, that there are a range of translations in between one vocabulary and the other. Double negation and other translations get you classical logic inside constructive logic. And then if you're only living in the classical world, you can begin to understand the constructive world by adding extra structure, whether that might be a topology, whether that might be a modality, whether that might be something. You can encode the constructive distinctions by means of extra conceptual apparatus to tell you the difference between classical facts and constructive facts. The insight that we've had since Gensen, though, is that in some sense, there's this sort of orthogonal representation between the rules governing this particular or that particular concept, whether that be implication or whether that be generalization or something else like this, or negation, disjunction, and the context in which those things are defined. One of Gensen's beautiful insights in the sequent calculus was that there's a purely structural distinction between classical reasoning and constructive reasoning, whatever that means. What is that difference and what does that mean conceptually? In discussions in philosophy over the last 20 years or so, this is focused in an area that the philosophers think of as bilateralism. You're in a classical universe if you're thinking of positive and negative information on a par, that you're not giving a priority to the positive, you're not giving a priority to the negative, you're saying they're both there. So here is a mildly bilateral natural deduction proof of Peirce's law. Here's a one technical slide. Well, that's this in the next one. Here it is. I'm proving A arrow B arrow A arrow A. Obviously true if you're thinking classically. How do I prove this? I assume A, and I'm going to straight away deny A at the same time. Why not? I contradicted myself. Then I'm going to pull a B out of nowhere because I've contradicted myself. I'm allowed to make that joke. I'm a relevantist. But still, then I made the deduction of that B vacuous, well, under the scope of the assumption of A, that's the positive one on the left. So I derive A implies B, discharging the A. Then I'm going to suppose A implies B implies A just for fun to do a modus ponens and get A. To get A, of course. I was thinking, oh my goodness, it was A implies B, but I'm using that as a minor premise for the A implies B. Associating conditionals to the left is really, really hard. Sorry about that. That's why nobody understands Peirce's law. Then I'm going to deny A again just for fun. Then I'm going to get a contradiction. And then I'm going to say, well, hang on, I'm ended up in a contradiction. But how did I end up in a contradiction? Only because I set A aside. And so, well, don't do that anymore. Retrieve that from being set aside and deduce A, and then discharge the only other premise that you used. And there's Peirce's law. just using the same introduction and elimination rules for the conditionals that Gensen gave us in a different kind of structural setting. The whole point in this that makes this bilateral is that the context in which this deduction is done was encoding positive and negative information. I was not only I was not only assuming A, but I was also assuming A negatively doing that. This is Parashow's lambda mu calculus, right? There it is, just annotate all of the terms. And here I've got an X, a positive variable for a positive judgment. And the philosopher's reading of the label alpha is that that's negative information, okay? And then there it is. It's exactly the same. But then you realize this, well, hang on. That's mildly bilateral because I was told how to go backwards. Yeah, here the only negative stuff was at the assumption level. The things that I'm concluding are just positive judgments or ending up in a dead end as a contradiction. There's no way of concluding something negative other than by explicitly introducing a notion of negation. Well, suppose I want to conclude negative stuff. Then I get a more symmetric calculus, and this is Curian and Habelan's calculus here of the symmetric lambda mu calculus, where now I've got three judgment forms, which, if you have your computer science lens on, you're thinking of these as commands, terms, and contexts. And as a philosopher dialogue kind of lens, I'm thinking of this as positive and negative information, assertions and denials, and just shit, we're in a clash where you're not blaming it on anything other than the entire context. But again, this allows for interesting structure. What does that mean? You tell me. One of the interesting things, though, is that this might give us a way of thinking about the relationship between extending this in a dependent type theory, that being positive and negative about propositions is different than being positive and negative about lists of things or something. Okay, last thing, speech acts. Speech acts, you don't just assert, you promise, you ask questions, you order people around, you commit to things, you do a whole bunch of different things. Philosophers have been interested in the way that, for example, conditionals like restrictors act as restrictors on each of these things, which is an interlacing between truth conditions and grammar. If I say, if A, then I promise to B, then I promise under the conditions that A is true. Okay, that doesn't count as a promise that you can enact on or anything like that if A doesn't turn out to be true. It was a conditional promise. Well, it's interesting that Martin Löf, said originally that, here we have this kind of interlacing between whether or not something counts as a proposition, or say whether or not something might count as a promise, depends not only on the grammar of the original things, but whether or not certain things turn out to be true. That's interesting, but the connection here is completely different. I'll leave you to read the abstract or think about this for a bit because I've got to stop. I'm going to tell you, though, tell me about the relationship between formal and applied type theory. Per, back in 1984, noticed that type theory can be applied in two different ways, as mathematics or as computer programming. But it seems to me that there's at least 3 or 4 different ways that this can be understood. Computationally, backed as processes of computation, or conceptually, backed as ways of human beings forming concepts and reasoning about things, or dialogically in terms of the public exchange of information. One of the cool things about type theory is it gives us a grammar not only of understanding each of these things individually, but possibly how we could understand their interaction. And I think that's a really interesting idea where we're interested in the interaction between human communication and what the hell computers are doing. But that's what I'm here to learn. So I should shut up. Thanks.